In this video, we'll be sketching a graph of a polynomial function. We're going to be following these steps. To sketch the graph of a polynomial function, we want to find the zeros of the function and then plot them as x-intercepts on the x-axis. Find the y-intercept by letting x equal 0 and then plot this point on the y-axis. We'll determine the end behavior of the graph of the function, and then if needed, we'll use test points to determine whether the graph is above or below the x-axis. The example that we'll be working with is f of x equals 2x cubed plus 3x squared minus 11x minus 6. Now, since this function is not in factored form, we're going to have to use all the tools at our disposal for finding the zeros of f. The first tool that I'm going to be using is my rational roots theorem, and it says that possible rational roots are of the form p over q, where p is factors of the constant term. So my numerator will be plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. The denominator, q, is chosen from factors of my lead coefficient, so I need plus or minus 1 and plus or minus 2. So I can list my possible zeros by taking each of these numbers in the numerator and writing them over each of the numbers in the denominator. So possible zeros are plus or minus 1 over 1, which we know is 1, plus or minus 1 over 2, which is 1/2. And then let's take the 2 over each of those. Plus or minus 2 over 1 is just plus or minus 2. Plus or minus 2 over 2, that simplifies to plus or minus 1. So I don't need to write that again. It would just be duplicating what I've already written. So now the 3, plus or minus 3 over 1, is the same as plus or minus 3. And then plus or minus 3 over 2. And now for our 6, plus or minus 6 over 1, which is just plus or minus 6. And then plus or minus 6 over 2, that simplifies to plus or minus 3, which I already have written, so I'm not going to duplicate. So this limits our zeros possibilities down to a lesser number now. I'm also going to use Descartes' rule of signs to figure out how many positive and how many negative zeros. First of all, if I look at f of x, that'll help me figure out how many positive zeros I have. This is a positive term, negative term, negative term. So I see only one sign change in f of x, which means that I have one positive zero. Then for my negative zeros, I need to look at the sign changes in f of negative x. And we can see that if I put a negative x in here, that'll change this sign of the term to a negative 2x cubed. If I put a negative x in here, when I square a negative, that becomes a positive, so no sign change there. So plus 3x squared. And then if I put a negative x in this term, I have a negative 11 times a negative x, which is a positive 11x, and then minus 6. So I have negative, positive, positive, negative. I have one sign change here going from negative to positive, and then here from positive to negative. So my number of negative zeros is going to be 2 or no negative zeros. So since I definitely have one positive zero, I'm going to check for that first by doing synthetic division. I'll do my whole numbers first, and then if need be, I'll check my fractions. But let me check positive 1. My function, I'm going to use just the coefficients here. So I'm going to write 2. Let's see, 3, 2, 1. I'm not missing any terms, so 2, 3, negative 11, and negative 6. Bring down my first term, so 2, 2, 5, 5, negative 6, negative 6, negative 12. So 1 is not a 0. Let me try negative 1. No, I want to check positive zeros, so let me check my next positive whole number, which would be 2. And again, 2, 3, negative 11, negative 6. Bring down my 2. 2 times 2 is 4, 7, 14, 3, 6. So I have a 0 there. That means that 2 is a 0 of my polynomial. Also, since I started with a third degree polynomial, my function now is second degree. This is second degree plus 7x. So I can factor that to get my other zeros. So 2x squared plus 7x plus 3. Either factor or use the quadratic formula. I'm going to factor. I need 2x times x. And then I need 3 times 1 for these numbers. I'm going to match the 3 up with the outer product. So I have 3 here and a 1 here. And both of those will be pluses. So setting this equal to 0, it looks like x equals negative 1/2 is going to be another 0. And x equals negative 3 will be another 0. So my third degree polynomial has zeros of 2, negative 1/2, and negative 3. Let me mark those as zeros of my function and plot them. So 2, negative 1/2, and negative 3. Now, since all of those zeros are to the first power, they only occur one time. That means that all of the zeros have odd multiplicity of 1. So my graph is going to cut through the x-axis on all of those zeros. Now, y-intercept. I find my y-intercept by letting x equals 0. So I have f of 0 is 0 plus 0 plus 0 minus 6. So f of 0 is negative 6, which means that my graph is going to cross the y-axis at negative 6. And finally, the end behavior of the graph. My function behaves like y equals, my lead dominant term is 2x cubed, so it behaves like x cubed, which is one arm up and the left arm down, since it's a positive 2 coefficient. So I'm ready to sketch my graph. My left arm is going to be down here, and my right arm is going to be up. And I'm going to cut through at each of these zeros. So I'll head up to this 0 and cut through. Then I have an appointment here at negative 1/2, so I need to come around and cut through there. And my y-intercept is negative 6, so I need to come down here and cut through my y-axis at negative 6, and then head up and cut through my x-axis at 2.